How do electrical engineers simplify complex block diagrams to transfer functions? Have you ever looked at a complex block diagram and wondered how electrical engineers turn that into something simpler, like a transfer function? Let's break it down step by step. Electrical engineers use systematic techniques to simplify block diagrams into transfer functions. A block diagram shows how different components in a system interact. Each block represents a system component with its own transfer function. Summing points combine signals, while takeoff points split them to feed into multiple blocks. One key method is dealing with cascaded blocks, which are blocks connected in series. When blocks are in series, their transfer functions multiply. For instance, if the first block has a transfer function called g1 of s and the second block has g2 of s, the overall transfer function becomes g1 of s multiplied by g2 of s. Next, we have parallel blocks. When blocks are connected in parallel, their transfer functions add together. If you have two blocks with transfer functions g1 of s and g2 of s, the combined transfer function is g1 of s plus g2 of s. Summing points are also important. At these points, multiple input signals are summed together, taking into account their signs. The output of the summing point is simply the total of all inputs. Sometimes, engineers need to move summing points and takeoff points around in the diagram. This can help simplify the layout without changing the overall transfer function. Feedback loops are another common feature in control systems. To find the equivalent transfer function for a feedback loop, engineers use a specific formula. This formula is g of s divided by 1 plus or minus g of s times h of s here. G of s represents the forward path transfer function, while h of s is the feedback path transfer function. The sign depends on whether the feedback is positive or negative. The simplification process involves identifying these configurations and replacing them with single equivalent blocks. This continues until the entire block diagram is reduced to one block, which represents the overall system transfer function. This is expressed as y of s divided by r of s, where y of s is the output and r of s is the input in the Laplace domain. For systems with multiple inputs, engineers calculate the transfer function for each input separately. They set other inputs to 0 and then sum the resulting transfer functions to find the overall response. When block diagrams become particularly complex, engineers might use alternative methods like signal flow graphs. These graphs representing the system with nodes and directed branches, allowing for transfer function calculations using Mason's gain formula without going through stepwise reduction. Simplifying block diagrams into transfer functions is essential for designing and analyzing control systems, filters, and signal processing circuits. Understanding the overall behavior of a system through a single transfer function is key for stability analysis and controller design. So, the next time you see a complex block diagram, remember that electrical engineers have a systematic approach to simplify it into a transfer function that captures the essence of the system's input-output relationship.